an important topic, that is STM32. It was designed by STMicroelectronics in the year 2007 by number of companies: Philips, Samsung, Atmel and Intel. Actually, STM32 is a 32-bit microcontroller. It is also known as 32-bit ARM Cortex, that is ranges from M0 to M7 core, whereas ARM means Advanced Risk Machine. Okay. Again, this STM32 is a low power consumption, high power performance, and its frequency ranges from 24 MHz to 800 MHz. Okay. It may be used in different applications like industrial, consumer electronics, or communication systems, whereas 3D printing, as well as networking tools, as well as smart bracelets, okay, and mainly in IoT devices also. In this, the core STM32, that is HL, that is the first IC. Later STM32L series were there, STM32F series was there. L series were used for low power and H series was used for high power consumption. Its ranges are F4 like G4 are been there, then were developed. These two are used they increase the entry level to high performance. It cores ranges from M0 to M3 or up to M33 or M85 also. Okay. Next, I am giving about basic architecture parts of STM32. This is basic introduction. What I said. In basic architecture, first it comes under memory structure. Nothing but it is a hardware architecture used to separate both internal bus and the data bus for fetching and boosting performance in STM32. Next one is bus. Nothing but it's having a nothing but bus matrix. It called as bus matrix means AHP. Nothing but it is a advanced high performance bus matrix to transfer data from CP2 memory as well as peripherals. Okay, another one is memory management. In this, flash memory are used to store program code, whereas SRAM is used to store data. Another models, they're having errors correcting code for reliability. Okay, another one is support ART, nothing but adaptive real time. These are used for zero adjustment for flash memory. Okay, next one is a CPU. It is the brain of microcontrol system. It is used to transfer data between CPU to memory. Okay, another one is in STM32. It's having a peripherals, nothing but it is used to communicate outside the world. These are rich peripherals. Peripherals. It is used to communicate communicate the peripherals outside the world. First one, it come across DMA, you already known, direct memory access. It increases the speed of operation as well as it is used to reduce the load of CPU. Okay, that is DMA. It is used to transfer the data within the peripherals. Another one is analog peripherals. These are conversions, ADC, analog to digital converter. Another one is DAC, digital to analog connector. Another one is operational amplifiers. Another one is timers, advanced timers. What they are going to do, they are used to generate signals, time delays, used to control the motors. Another one is NVIC, nothing but is a nested vector interrupt controller. Nothing but it is used to provide low latency and real-time interrupts. Another one is GPIO, nothing but general purpose input output. It's having push as well as pull, open drain, like pull up or pull down. Another one is peripherals are in this peripherals are main UART, I2C, inter-integrated circuit, another one is CAN, another one is SPI. These are the rich peripherals that is used to support by STM32. Another one is it is used having a power, nothing but it requires a power from 2.2 to 4.6 volts. It may be VDD or VSS. Another one is it's having a 3 process, that is step up. Another one is stop. Step up means it can be written as a sleep mode. Another one is stop. Another one is standby. These 3 comes under power. Nothing but in sleep mode, the CPU or peripheral can be off state. Stop means the functions are paused. And standby means it is used to wake up the function. It is used in this ultra low power signals are used. Okay. Another one is in STM32. It is used to communicate data within the peripherals. For that, its cortex ranges from M0 to M85. Next, it is used to support MicroPython language. You can write the codes by using C. Better you use C++, so thus the errors can be reduced. In this flasher, STM32 has been used for it is a free software for PC utility. Okay. How the STM architecture look like? Mainly it consists of STM32 chip. Next it is followed by Cortex-M0. Let's it's followed by bus matrix. Later it is followed by 3. First one is flash, another one is peripheral, another one is SRAM, and these 3 are followed by nothing but UART, I2C, SPI, SPI. This is the simple introduction on STM32 Cortex-M0. ARM also known as Advanced RISC machine. It was discovered by ARM company in the United States. Okay. Another one is it is used to support pipeline process. That is pipeline process means in the instruction are having 3 operation, perform 3 operation, nothing but fetch, decode, another one is execute. You can see this is the architecture for pipelining. I am telling about pipelining. Nothing but pipelining means it is used to support 3-stage pipeline process in STM32. Nothing but fetch, decode, execute. These 3 instructions are to be performed while fetching an instruction. Fetch, decode, execute, like that. If we take a 3 operation, addition, subtraction as well as multiplication. For addition, it is used to in first cycle. This is the second cycle. This is the third cycle. Okay, like that. In the first instruction, the addition is to be fetched. In the second cycle, the addition is used to be decode. In the third cycle, the addition is to be execute. Whereas in second cycle, the subtraction is used to fetch, whereas the subtraction is used to decode, whereas multiplication is used to fetch. Like that, the pipelining process are to be supported. Whereas in ARM 7 TDMIS also, it is used to follow thumb instruction set. It is a 16-bit. Okay, like that, STM also it is used to support pipelining process. Okay,